Hey guys, this is Michelle Kittner of the Gulfport School District, and this is the second in the two-part video on proportional relationships. By the end of this video, you should be able to represent a proportional relationship in an equation. The standard that goes with this video is 7.RP.2, and we're focusing on part C. The vocabulary for this standard is proportional relationship, and remember, that's the relationship among a group of ratios that are equivalent. So if we have equivalent ratios, they're proportional, they have a proportional relationship. The constant of proportionality is what a unit rate is called in a proportional relationship. And just to review a little bit from 6th grade, independent variables are the variables in an equation whose value determines the value of other variables. And then a dependent variable is a variable whose value depends on the other values of one or more independent variables. So remember, independent variable, if you have a graph here, independent variable is going to be on the bottom. And usually, a dependent variable, when you have an equation, is going to be on one side of the equal sign by itself. So just remember those little key things there. Okay. If you watched the first video, then you know that we had 3 ratio tables that we were dealing with, and we were deciding if they were proportional. We're going to carry those ratio tables over to this video and write equations for each of them. So when we write proportional relationships as equation, the first thing we always want to do is make sure that that relationship is actually proportional so that we can proceed with writing the equation. So let's see. Let's see if we can reduce all these to the same ratio. So 2 to 1 does not reduce. It's still 2 to 1. Let's find a smaller equivalent ratio for 4 to 8. They both have a factor of 4. So when we divide, we get 2 to 1. 14 to 7 both have a factor of 7. And when we divide, we get 2 to 1. 20 to 10 both have a factor of 10. And when we divide, we get 2 to 1. 22 to 11 both have a factor of 11, and when we divide, we get 2 to 1. So is the relationship proportional? Absolutely, it's proportional. So we can write this equation. In this example, let's see what the dependent variable is. Well, let's say this is at a restaurant. The number of people that can eat at the restaurant at any one time depends on the number of tables. So people depends on the number of tables there are, and the restaurant can have any number of tables in there as long as it fits in the restaurant, but they can have different numbers of tables in the restaurant or tables that they're seating people at. The constant of proportionality is the unit rate, and right here the unit rate is going to be 2, but let's look at that a little bit differently. What the constant of proportionality tells us is that for every one of the independent variable, that's how many we have of the dependent variables. So for every one table, we have 2 people. How did I get that? If we have 4 tables, we have 8 people. Well, how do we get that? We multiply, right? So we're saying the constant of proportionality, 2 times the independent variable of t, gives us the dependent variable. And that's where this equation down here comes from. The dependent variable equals the constant of proportionality times the independent variable. Here's our equation. And this is, remember, is just because the number of people is equal to 2 times however many tables there are. 2 people are sitting at each table. Let's look at the green example. So here, is the relationship proportional? Well, let's reduce these down to their smallest form. So 120 to 2 both have a factor of 2, which reduces to 60 to 1. 240 to 4 both have a factor of 4, so this reduces to 60 to 1. 360 to 6 both have a factor of 6, so this reduces to 60 to 1. 480 to 8 both have a factor of 8, so this reduces to 60 to 1. So yes, this is proportional. These are all equivalent ratios. They reduce down to the same thing. They are proportional. Well, let's see. The dependent and independent variables. So if I'm driving at a constant speed, here, it would be 60 miles in 1 hour. If I'm driving at a constant speed, then the distance that I travel is going to be dependent on how long I drive. So we have the dependent variable would be the distance, and the independent variable would be time. The constant of proportionality, for every 1 hour that I drive 60 miles, or the unit rate. Now, our equation, if I want to find how far I drive, I just multiply 60 times the number of hours I'm driving, or the dependent variable equals the constant of proportionality times the independent variable. All right, let's look at the gray example. Okay, is this a proportional relationship? Well, when we reduce all these, can't reduce. There's not a smaller equivalent ratio here. 25 to 5 there is. They both have a factor of 5, so we can reduce those and get 5 to 1. But these are not equivalent. So this relationship is not proportional. We're not even going to worry about creating an equation from it. Maybe we can, maybe we can't. We're not there yet. So let's look at an example from start to finish. Johnny reads 15 pages in 20 minutes, 12 pages in 16 minutes, 36 pages in 48 minutes. Is this a proportional relationship? If so, draw a graph and write an equation to represent the situation. And then, how many pages can Johnny read in 1 hour? Okay, let's put these in a table and then decide if it's a proportional relationship. I put time on top and pages on bottom. So let's see, for time we have 20 minutes, 16 minutes, and 48 minutes. So I'm going to put them here in order. I'm going to leave this first one blank because I want to put the most reduced ratio there, the smallest equivalent ratio there. So I'm going to put 16 minutes, 20 minutes, and 48 minutes, and then their equivalent pages. So 16 minutes, that was 12 pages. 20 minutes was 15 pages. 48 minutes was 36 pages. Okay, let's reduce these and see if they're proportional. So 16 to 12, both of those have a factor of 4, and that would reduce to 4 to 3. 20 to 15, both have a factor of 5, so it reduces to 4 to 3. 48 to 36, both have a factor of 12, so that reduces to 4 to 3. So these are proportional. Is it a proportional relationship? Absolutely it is. I'm going to take this 4 to 3 and I'm going to put it up here. It's still a proportional relationship with all of them because this is going to be 4 to 3. So now we want to put it on a graph. Something to think about with this graph, I didn't have enough space on here to create a graph that went all the way out to 48 and 36. So what I did was I made each of these little lines be 2. So 2, 4, 6, 8, 10. And so each of the heavier lines is going to be a 10. So 10, 20, 30, 40, 50, and 60. Same with the y-axis, 10, 20, 30, 40, 50, and 60. You need to put those on there so that the person looking at your graph knows what they're working with. Now, we see that the independent variable, P, is on the x-axis. So we want to put our points, we'll call them points A, B, C, and D. I'm going to go ahead and write what they're going to be. So if P is on the x-axis, remember it always goes X, Y. So we're going to have 3, 4. Point B is going to be 12, 16. Point C is going to be 15, 20. And point D is going to be 36, 48. Okay, so I'm going to change colors real quick so that these stand out a little more. And let's put these points on. So point A, 3, 4. So we're going to go 2. The next will be 4. So right in the middle is 3. And then we're going to go up 2, 4. And so that point's going to be right about there. 12, 16, point B, so we're at 10, 12, up 10, 12, 14, 16, so we're right there. 15, 20, so 10, 12, 14, and right between 14 and 16, and then we go up to 20, and then 36, 48, so 30, 32, 34, 36, we go up 10, 20, 30, 40, 2, 4, 6, 8. Okay, now let's draw a line. Okay, we know that our line is going to pass through the origin. Because it's a proportional relationship, it has to pass through the origin, so that's where I'm going to start. So up, 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 up. And continues on. My dots aren't perfect, but we can see that, there we go. It does pass through those, and it does pass through the origin. There we go. All right, so there's our graph. We have found that it is a proportional relationship, and we drew a graph. Okay, let's write an equation. Is the relationship proportional? We said yes. The dependent variable, remember we said it's on the bottom of the graph, the x-axis, and we put p there, and t would be the independent variable. I'm sorry, I did those backwards. I didn't read the question, I just assumed. So here we have our dependent variable is going to be time, and our independent variable is pages. I think that's what I said, I just wrote them in the wrong spot. Okay, our constant of proportionality. Now this one gets a little weird. Remember we have this 4/3, and our constant of proportionality is our unit rate. So we want to get 4/3, and we want to find the second number to be 1. We had to divide by 3, so here we divide by 3, and we get 4/3. So our unit rate is 4/3. Our constant of proportionality is 4/3. Your constant of proportionality is going to be your smallest equivalent ratio. So then we write our equation. We say that Johnny can read, we want to know 45 pages. Johnny, well, we're not to there. Write the equation. Johnny can read, it takes him, dependent variable equals, it takes him 4/3 of an hour to read a page. So he can say time equals, for every page, it takes him 4/3 of an hour. So t equals 4/3 times p. All right, here's our graph, here's our equation. Answer the last question. How long will it take Johnny to read 45 pages? 2 ways to do this. First, let's look at the graph. So we can come over here on the graph and we can find 45 pages. So 40, 42, 44, 45, and we can draw a line up to meet the graph. Then we can take that where it met the line, and we can draw over to see where we are. And we're here at 60. So it's going to take him 60 minutes. These are backwards. No, they're not. Oh. "45 pages, how many minutes?" Okay. So we can see that it's going to take him 60 minutes or an hour to read 45 pages. The other thing we can do is just plug in. Time equals 4/3 times 45. Okay, we're working with fractions, so we've got to change to an improper fraction. Time equals 4/3 times 45/1. Well, let's see, 45 times 4, we get 20. Carry the 2, 16, 18. So time equals 180 over 3, and when we divide that, we get time equals 60 minutes. Same thing. So you can either use the graph or you can use the equation. The equation is going to be more accurate. So I hope now you know how to create an equation from a proportional relationship.